Admin of Code 2024, day 12, garden groups. So we're gonna get another grid, and it's going to have letters that represent different, like a different vegetable or crop that's growing in each section. And so like the A's are here, and then there's a section of B's, and there's a section of C's, there's a single D, E, etc. And basically, for each crop, or for each region, which is a like group of connected crops, I need to get the area, which is the number of blocks. That's pretty easy to count by the perimeter. So like in this case, the A's is 1, 2, 4 across the top, 4 across the bottom, 1 and 1, so it'd be 10. And I think that's what they show down here, the perimeters. And at first I thought this was gonna be so. And basically, what we need to do is then multiply area times perimeter to get a cost, and then sum up all the costs of the different regions and get a value. At first, I thought this was gonna be very easy. If every region with an A in it is the same region, because I can basically just walk the grid, and then for each one of these, I can count the A's. I can basically keep a list and say like a dictionary. I'll say like, oh, for A, this square has 3 sides. This one has 2 sides. This one has 2 sides. This one has 3 sides. So I can count the perimeter. I can count the number. I can just multiply them together. That's pretty easy. The challenge becomes that they give us an example down here with all these X's and O's. See the 4 X's in the middle here, where this is 5 regions. Even though 4 of them have X in them, they're not touching, so they count as separate regions. So I can't just singly walk this through. I got to actually worry, the letter doesn't matter except for what it's next to. So this X, the X at the top left here is different than the X at the top bottom right here. So I can't just simply walk once and count based on letter. Yeah, let's go ahead and take a look. I'm gonna grab this region right here, and that will be our example. Jump over here into VS Code. I will do gen day for day 12, and that pulls my input and gives me a stub. I will also create example.txt. I really should have gen day just touch that as an empty file so I can just paste into it. I'll remember to add that today. Input wise, you can see we do have, if we do like control F for N, you can see there are multiple areas with N with the same region. And so I can't just look at the letter because those are different regions. So we're gonna have to use like a flood fill, which is basically a breadth first search, which we've done a couple times already, at least once. Many times in admin of code. Let's see. We're going to read this in. We're going to strip the lines, and we're going to have a list of lines, which I think looks good. Let's do, we can call this grid. So what we need to do is, let's first find our regions. So we're going to say regions equals and a list. Now, what do we need? We need to walk over our things, and when we find a letter that we haven't seen before, we will basically try to step both up and down, or all 4 directions, up, down, left, right, and check if those are the same letter. If they are, add them and keep flooding till there's none left. So it's going to be we're going to have a queue. So we'll do from collections import deck, and so we're going to say for let's do our standard thing here, and we do num rows equals len grid, num calls equals len grid 0. So we can say for r in range, remember to type range this time, num rows, for c in range, num calls. Well, let's see, we're gonna need scene equals set. We'll say if r comma c in scene continue. We already counted that one. We don't need to do it again. Otherwise, we're gonna make our queue. We're gonna make our flood fill. So if we've already seen the spot, we don't need to worry about it. If not, we need to count. We have a new region. We need to count it. So we're gonna do that by, let's say we're gonna call this region equals set of. We can actually do RC. So we'll initiate it to have that point in it. Q equals deck with r comma c in it, like that. And so now we can say, say, while q And then what do you do? We need to check each of the points. So we'll say, I guess we can say, I guess we'll do this way. We'll say set, and then we'll say region dot add r comma c. We'll add the region. We'll add the spot, and then we'll say for dr dc in. This will be -1, 0, 1, 0, 0, 0, -1, and 0, 1. So we go for each direction. We're going to if r plus dr. We better check the bounds first. 0 is less than or equal to r plus dr. It's less than num rows, and 0 is greater than or less than or equal to c plus dc is less than num calls, and grid of r plus dr, place and spell, c plus dc equals grid of rc. So basically, if we're in bounds, if the next point's in bounds, and the next point's the same as the current point, we will q dot end, and that will be, we're just going to add r plus dr, c plus dc. We add that point to the queue. We actually better pop that queue point. So we'll say r comma c equals, oh shoot, we already used rc. rr comma cc equals q dot pop left, and this becomes rcc. This is the same. This becomes rr. This becomes cc. This becomes rr. This becomes cc. This becomes rr. This becomes cc. And I probably should just do, hold on, this is gonna be cleaner. Next r, next c equals r plus rr plus dr, cc plus dc. And now we can come here and just make this next r, next c, next r, next c. That we want the same, and then this will be next r, comma, next c. Okay, so we have, for each point, we're gonna get to the thing. Now, every point, when we get to the end of this queue, so we've basically said, we found a point we found a region we haven't hit before. We add it to the queue. Now, we're going to, let's see, we're going to get the values out of the queue, we're gonna add them to the region, we're gonna check every direction to see if we can keep growing. When our queue gets empty, we'll come down here, when we basically have hit the full region, the region is now there. We'll say regions dot append region. Now we've got the region. We better also say scene dot add, how do I think it's like this. I think we better do a test here because my sets are not that good. Let's see. So if I have a set equal s equals set like this, and we can say s dot add 3, s dot add 2, 3. Oops, better add that as that. Now if s is my 2 points, and if I have another set, which is we'll call x equals set like this, 4, 5, 5, 6. I'm just making up some numbers here. If I do s plus, not plus equals, or equals, I think I want x. What does s equal? Yeah, that's what I wanted. Okay, so scene or equals region. So now all of those things in region are now in the scene set, so I can skip over them if I run into them in the future. Let's see what we get here. I think we're looking potentially solid. Python, oops, day 12 example. That's not supposed to run that long. Let's see. Oh, I probably need to add things to scene sooner because I'm gonna just keep going back and forth on the same points. So that's no good. Let's do that. We're going to region add here. We're going to scene.add rrcc. Get rid of you. All that work for nothing. We still aren't checking. We aren't checking scene. If nr and c not in scene, and that went a lot faster. So we just need to move our scene check more frequently. We gotta check our scene more common. We're keeping scene more common. More regular. So how do I tell if this is good? Let's check my example. I expect to see 0, 0 through 0, 3 and 1, 0 through and row column. So this would be 1, 0 through 1, 3. 2, 4. How many is that one big set? No, I got a couple sets here. Oh, there's more. There should be okay, that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That might be right. The next region goes from 1, 5. So 1, 5. That's the eyes, and it should be 4 long. 1, 2, 3, 4. Okay, yeah, I think we got it. I think we're in a good spot. Okay. So if that's the case, then for each region, we just need a way to calculate the areas of the region, or the perimeter, I guess is what we. I might move this part into a function. Let's see. Well, I don't know. Okay, because I think I want a function for area perimeters. I'm not sure. Yeah, let's make a function for perimeter. Def perim. I spell perimeter. That's gonna bug me. I'm not gonna be able to say it the wrong way. Per perimeter. Okay, I was doing it right. Perimeter takes a region, which I will type hint that is a set of what is it? Tuples. A set of tuple of int. Yeah, that's interesting. And we're gonna go to a int, and that needs to not be there. And what do we? So how do we do this? So I kind of talked about this in the beginning when I was looking at the thing. If I look at any given point, it's got 4 sides, and the sides that are going to be included in the perimeter are the ones that are not next to the same. They're not in the same region. So basically, I need to figure out for each side. So I'll say for r comma c in region. I just need to say neighbors equals r plus dr. Let's see, we'll just say this is equal 1 for dr dc in. I'm gonna grab my same in view right here. I'm gonna go every possible direction, and I will only put it in here if r plus dr c plus dc. So if that point in region. So this right here is going to give me a list. I'm going to loop over all the possible directions I could go, up, down, left, right. If the new point is also in the region, then I'm just going to put it here, and I can put a sum here, or I can just do a len, like that. So now I'm going to have the number of neighbors. I'm going to call this num neighbors. And so now I'm going to total equals 0. So each spot I'm going to add total plus equals 4 minus num neighbors. So it's going to get all 4 sides minus the number of neighbors. And then I return total. And so down here, I'm going to say, we can check this. Let's see. So if we do this Python, I love Python minus I. And now we say perimeter of regions sub 0, 18. That was this one right here. I think that worked. I think the next one was I, so we should get an 8 if we do sub 1. Yeah, that's looking right. Okay, So now I need to do part 1 is equal to, we're going to do sum r for r in regions. So I'm going to go sum over each region, and for each region, we're going to multiply len r times perimeter r. And 1930, that is correct. And it's moving very slowly. Don't like that. Why are we getting caught in a loop here? I'm going to put a breakpoint right here. I went up setting, I have a video where I show how to set up the debugging so that I can have a debugger for set for both example.txt and input.txt. I'm gonna go ahead and put a break here. I'm curious to know, am I getting stuck in this area or am I getting stuck in the perimeter calculations? Let's run this. And the fact that I've not hit this breakpoint implies I'm getting stuck in here. So let's stop you. Continue, let's see. I suspect I'm gonna make it to here just fine. Yeah, so those are going fine. I'm gonna step up here. I'm gonna step up to like too many spots. Let's go to here where let's see. So I can do I can get some regions. Okay, here I've got a region that I'm failing on. Let's see. Let's pause here. Come here and do grid RC. Why not? Let's step maybe. Is E. We're getting stuck in the E region. Where's my input? Okay. Which R and C are we in? R comma C 09. How would I be getting stuck in here? Maybe we better put a print in here. It's ugly, but it'll probably help. Let's do a stop here. Let's see. Let's do a print view. Now I'm going to do this in debug mode because I want to see within a specific one. Like I don't want to go beyond. So if I run again, that works fine. So you can see my queue goes all the way up, and we get a region. We run again. Now here's where we're getting bad. Okay, so what's getting added here? 618 is showing up over and over again in our queue. So we're having a problem here where our queue is still getting things that, because, okay, we're adding it to scene here. We only add it to scene once we process it. But when we add it, really we want to add it to the scene here when we queue it, because once we queue it once, it's done. The point is over. So let's do this. We'll come down here and we'll do scene dot add nrnc because we put it in the queue. We don't need to hit it again. I suspect this is going to fix our problem quickly. Let's see. Make sure our input still works. Okay, still get 1930. Remove our print statement. And now input, and we get something very quickly. Decent debugging there. Let's see. And we got a gold star. All right. Over almost 18 minutes, and we are just to part 2. It's starting to ramp up. I'm going to go read this. All right, part 2. It gets a little trickier. We're going to do the same thing, but this time instead of counting the full perimeter and multiplying by that, we're going to count the number of sides. So if I have 3 straight in a row, like 3 up fences in a row, that counts as 1 side. And so up here, you know, this A, the A region goes from being a perimeter of 12, 4 on the top, 4 on the bottom, or sorry, 10, 4, 4, 1, and 1, to being a perimeter sides of 4, top, right, left, and top, bottom, left, and right. This C one's more interesting. It's got 2 different on the left side, 2 different on the right side, 1 up, 2 up, and 2 down. So it actually becomes 8. I hope that's right. Let's see. C has 8. Yep. So they say they give us a warning to be especially careful about this situation with the A's and B's. The B's are very easy. They each have 4 sides. The A has 4 outer sides, and then the tricky part is we have to the corners don't touch. So there's 4 sides around B and 4 sides around the other B. So there's 12 total sides there. This doesn't count as 1 long side going down the middle and 1 long side going across the middle. All right, that's it. It's been a fair amount of time. It's been a couple hours. I had to, between stopping to think about how this is going to work and having to take my kids to school. it's been a while. So I think what we're going to do is we're going to try to count, if we think about it, the number of corners on a shape that is enclosed. So like it's the path forms a complete circle, or well, not circle, but enclosed shape. The number of corners and the number of sides is the same. And by that you can think about if you start at any corner and you walk to the next, you walk along a side. That, and let's say you assign the corner to the side you walk along, then you assign the next corner to the side you walk along. And when you get back to the beginning, you'll have assigned each, so each corner kind of lines up one to one. And we can count corners by looking at a couple different shapes here. Let's see, I'm messing around with this a little bit because we can go with this. You have a corner. If you have what we're going to do is we're going to loop through all the spaces in the region, and we're going to log if it has an up fence, a down fence, a left fence, or a right fence. And so if a space has an up fence and a right fence, then it's a corner. If it has an up fence and a left fence, it's a corner. Like those are the easy cases. Or here it's got a down fence and a right and down and the left. So those are corners. The trickier parts is also these corners over here, like on the edge of 9 here, where if it's got an up fence and you go up and left and there's a right fence, that's also a corner. But we don't want to count that corner twice if it looks like this. So we have to sort of be careful about that as well. So hopefully that these drawings are not very good, but maybe it'll make more sense when we start coding it. So we can come up here and start a def sides region set tuple int and goes to an int. And so what are we going to do? The first thing we're going to do is we're going to do for r comma c in region, and we're going to need to log. I guess we need to create our sets. There's probably a better way to do this, but I'm just going to go up, down, left, right equals set new set for blank in range 4. We'll make 4 sets. Now we can, for each set, we're going to say, for each thing, we're going to go over it and we're going to say, so if we can say, when we are looping through our point, if r minus 1 comma c, so we've gone up 1, stayed in the same column, not in region, up dot add r comma c. Similarly, let's see if we can grab this. This can be it can be some kind of repeated code here, but if up r, I guess we want to do +1 is not in the region, then we're going to add a down fence. So this one has a down fence. If r comma c minus 1 not in region, then we will add that means the left fence is there. And if r comma c plus 1 not in region, right dot add r comma c. Now we've got we got lists that show who's got an up fence, who's got a down fence, etc. So now we're going to get a count, say equals 0. And we can say we need to either look at all the ups and downs or all the lefts and rights. We'll do ups and downs for the sake of for arbitrariness. So we'll loop over all the ones in up. Now there's 4 conditions. If r comma c in left count plus equals 1. So, and we can do the other easy one. If r comma c in right count plus equals 1. Now, if r minus 1 comma c minus 1, so we've gone up and left. That is, we are at this up one right here, and we've gone up and left here. And if that has a right fence, then this is also a corner, but only if there's no right fence or no left fence on this one. So we're going to say if that in right and r comma c not in left, because if it's in left, we've already counted this corner. We don't want to count it again. Count plus equals 1. And then we'll do the same thing. We'll say if we'll go up, we're still looking up, so we're going to see the other side in left and r comma c not in right count plus equals 1. Now we need to do that whole thing again, but for down with some slight changes. So we'll say down here. Now this one, these two are going to be the same. This one, instead of going up a column, we're going to go down a column. And then I think, let's see, this will be if right and left. Let's see, minus 1. We go down and that. We want to check if it has a right fence, but not a left fence. So this should be the same. And so then we can just return count. We'll take a little leap of faith here and try this. The result will be sum len r times sides r for r in regions. And we can Python day example 1206. That matches. Let's try it with our input. We got a number. We got a right number. Cool. That was a tricky one to think about. I think I really like the corner idea. That was much easier to count corners than to try to worry about successive sides. So it was still a little tricky and probably could be cleaned up some, but yeah. Thanks for hanging out with me today. I'll be back tomorrow. Bye.